Dear students, we can move to Kepler's third law of motion. In previous class, we have discussed Kepler's first and second law. Now, today's Kepler's third law of motion. Kepler's third law of motion tells us this is Kepler's third law of motion, or this is also called the law of periods. Periods means what time. Kepler's third law of motion and law of periods tells of the relation of time period. It gives us a relation of time period to the average radius of a planet. Time period here refers planet. Time period here refers the time taken by a planet to make a complete revolution around the sun. That is the time period. Average radius. It is the average. So you know that the position of the sun, it lies in one of these foci. I have told you in previous classes. We in radius we take here the average radius. Suppose this is the position of the sun. Suppose this is the orbit of one planet through which the planet is moving around the sun. This is the orbit of one planet. Suppose this is the second and this is the third. This is sun here. Suppose this is the average radius r1. इसका suppose मैं लूँगा r2. Suppose इसका r3 होगा. The time taken to complete, suppose the planet starts its time here. One complete revolution means time period means when it reaches again at point A. It starts from point A, when it again reaches that point, it is the time period. And time period of this is depends upon it is average radius. इसका time period अगर suppose it is point B here, it starts from point B and again it reaches at point B, it is its time period. इसका suppose it starts from point C and again it reaches at point C, it is its time period. The time period of to make complete one elliptical path, it is called its time period. Kepler say the square of time period is proportional to the cube of its average radius. That means in mathematical, that means if I write in square of time period, you know that time period is a time taken by planet to complete one of its revolution. The square of time period is proportional to the cube of its average radius. In mathematical form, we see that t square is directly proportional to r cube, where the square of the time period is directly proportional to the cube of its radius. It is for one planet. Suppose in planet this, suppose its time period is t1, its radius is r1. That means we can write here t1 square is directly proportional to r1 ka whole cube, or we can say t1 square is equal to constant r1 ka whole cube. Okay, this first. For this planet, we can say suppose its time period is t2, its radius is average radius r2. We can say similarly t2 square is equal to k is constant r2 ka whole cube. If we divide these two, we can say t1 square divided by t2 ka whole square is equal to r1 whole cube divided by r2 whole cube. If we know the time period of one planet, and time period of another planet, and we know the average radius of planet, we can find out the average radius, that means how far another planet is away from the sun. This is a useful relation. This relation is used for calculating the average radius or average time period for a planet to complete around the sun. This is the mathematical form of this. That means the square of time period is directly proportional to cube of its radius. The cube of its radius. This is that means if you look here, time period is directly proportional to r cube. That means जितना average radius कम होता है इतना time period भी कम होगा इसमें. That means thus larger the distance of a planet from the sun, thus the large will be the period of its revolvation around the sun. That means jitna they are directly proportional. See, this is also a relation. That means large the distance of a planet from the sun, the large will be its period of revolvation around the sun. That is why we know that planet is the farthest. That means the period of revolvation of farthest planet Plato is around 240. Plato, which is the farthest planet for the sun. That means it is lies in the outer ring. It is period of revolvation is 247 years. That means period of revolution 247 years. Because from this relation जितना average radius जितना ये radius जितना planet नज़दीक होगा इतना time period कम होगा, जितना ये दूर होगा इतना time, because they are having direct relation. The nearest planet, that is Mercury, it is having period of revolution of 81 days. Our Earth period of revolution is almost 365 days. You know this, it is 1 year. Okay, so this law can also be also be derived from Kepler's third law. If you remember the Kepler's third law, from the Kepler's third law we can also derive the law of this law of periods. Kepler's third law अगर आपको बताएं, suppose we take a sun here, sun, it is a mass m, suppose it is the mass of the planet, and m, small m is the mass of the planet, and capital M, small m. We can deduce the law of periods from Kepler's law of this Newton's law of gravitation. Prove Kepler's third law. From the Newton's law of gravitation, we can prove Kepler's third law. Suppose m is the mass of planet, small m is the mass of planet, m is the mass of sun. Suppose a planet of mass m is moving around the sun in a circular orbit of radius. Suppose the average radius is r. With the orbital speed. It is having speed. Suppose its average speed is v. It is average speed. Let m be the mass of sun. The force of gravitation between the sun and the planet provides necessary centripetal force. Necessary centripetal force is provided. The force of gravitation between the sun and the centripetal force is the force with which the body is able to move around a circular path. That is provided by force of gravitation between the force of gravitation between sun and this. That is Newton from Newton. That is Gm small m divided by r square. It is provided by centripetal. You know that centripetal force is equal to mv square divided by r. R and R cancel, M and M cancel. Ultimately, we get V square is equal to GM, capital M, divided by small r. This is the V square. We get V square. V square is equal to. But orbital speed, if you remember, orbital speed is equal to circumference divided by period of revolution. Circumference divided by period of revolution. Circumference of this, it is 2 pi r, it is of circular for 2 pi r divided by period of revolution is t. Period of revolution is t. When we substitute in this equation here, substituting v in equation first, it is v square. It becomes 4 pi square r square divided by t square is equal to gm divided by r. अगर मैं इसको उल्टा कर लूँगा, इसको भी उल्टा कर, t square divided by 4 pi r square. It is all mathematics. R divided by gm. Ultimately we get t square. It gives me t square. ये यहाँ से शिफ्ट हो गए. We can get t square is equal to 4 pi divided by gm r square or r cube. This 4 pi, you know the value. G is universal gravitational constant. We know m is the mass of the sun. We know this. This becomes a constant. This value becomes the constant. That means t square is equal to constant divided by r cube. R cube. T square is directly proportional to r cube. That means law of periods can also be derived. This proves Kepler's third law, where this is constant. We know the value of 4. Pi we know. G is the universal gravitational constant. M is the mass of the sun. We know that means its value is constant. Ultimately we get T square is equal to r cube. That means this proves Kepler's third law of motion. That means we can also deduce Kepler's third law of motion from Kepler's third from Newton's law of gravitation. This is all about Kepler's third law of motion. I hope you have got it. Simply this law, what does this law say? This law says square of time period. The square of the time period is proportional to, simply it says square of time period is, it gives the relation of time period to the average period of a average radius of the planet. Simply the square of time period is proportional to the cube of its average distance, to cube of its average radius to the cube of its, that the square of time period is directly proportional to the cube of its average radius. From this, for one planet it is this d1 divided by r1 whole, for second planet it is this. From this is an important relation. With the help of this relation, if we know the time period of one planet, time period of another planet, and radius of one planet, we can say the radius of another, average radius of another planet. That means average distance of a sun from the other planet. That means we have also concluded as the nearest planet, the planet which is nearest, having least this revolution of time, the planet which is farthest having large this period of time. That means the larger the distance of a planet from the sun, the larger will be the period of revolution around the sun. The period of revolution of farthest planet, that is Plato, is around 247 years. This is because of this relation. And for the nearest planet, which is Mercury, it is having only 81 days. I hope you have got. Inshallah, we will meet in the next class. Thank you very much.